Okay. All right. So these are both exchanges, and again, you have to do them in PEMDAS order. So you got to divide by 2 and then shift to the right quarter pi. So I'm going to do this on the graph. I think it is easier. If I divide pi by 2, or if I divide negative pi by 2, I get negative half pi, which would be the second line over. And then I have to shift to the right quarter pi. So that's where my first asymptote is going to be. So negative quarter pi. So I originally my asymptote is at 0. If you divide by 2, that's still 0, and then you shift to the right quarter pi. So that means I have one at quarter pi. And then the one that was pi, you divide by 2, that would put you at half pi, and you shift to the right quarter pi. So again, once you get the pattern, there's one every 2 spaces. I could go in and put all of these in if I wanted to. This is 3/4 pi. Okay, so on my key points, it was at pi over 4. You divide by by 2, which makes it at pi over 8. And then you shift it over quarter pi, which would put it at 3 pi over 8. And then the next one was at half pi. You divide by 2, that puts it at quarter pi. Shift it over a quarter pi, that puts it at half pi. And then the last one was at 3/4 pi. Divided by 2, that puts it at 3 pi over 8. Shift it a quarter pi over, that puts it at 5 pi over 8. But let's say you don't know where any of those are. But you can find half pi 0, right? Because that one's half pi 0 would be right here. And we know what this looks like. So I can pretty much figure out where 3 pi over 8, 1 is, and 5 pi over 8, negative 1. Oh, sorry. It's negative 1. Sorry. All right. And then again, we could repeat that over and over and over again because it's periodic. Are we kind of a little bit okay? Kind of? Okay.
Are we ever going to get to anything that are not periodic?
No. Wait, I lied. Yes, we are. But not really, because we're not going to spend a lot of time on this. But the inverse ones, the inverses, arctangent, arcsine, they're not periodic.
Oh, lovely. That's beautiful, Katie.
All right. So this is secant. Ben, are you with me?
Oh, I am not.
I went
Again, I said I am. Guys, I got it in my head.
So this is like we did the other day. It's a trip around the unit circle, graphing what each thing would be. So secant, remember, we're going to secant first. Secant is 1 over x. So they gave you the ordered pair, and you just have to put 1 over x. So on that first one, I mean, that was right on where I am, but that wasn't. Okay. 1 over x, so that would be 1 over negative 1. So it's negative 1. 1 over negative square root 2 over 2. I'm going to go down in this space by 2, and I'm going to do that. 1 over negative square root 2 over 2. That is 1 divided by negative square root of 2 over 2, which we keep, switch, flip. And now I have a radical in the denominator, which I have to rationalize by multiplying both the top and the bottom by square root of 2, which would give me 2 square root 2 over negative 2. And what happens to 2 over 2. It cancels or it ones out. So I end up with negative square root 2. That's going to happen every time you have 1 over those.
So it's just negative.
All right, what about this one? 1 over x in the next one. So it'd be 1 over 0, which is undefined. And the next one would be square root 2. The next one would be positive 1, and then square root 2, and then undefined, and then negative square root 2, and then negative 1. If you remember doing this the other day, we don't need those ordered pairs in the middle, so you can scratch those out. And we're just plotting negative pi negative 1. So I'm going to put a dot at negative pi negative 1. Square root of 2 is about 1.4. So that's going to be at negative 3/4 pi. It's going to be about negative 1.4. And this is counting by halves, by the way. So it's like right there. Then anytime I have undefined, what am I going to draw in? An asymptote. At negative pi over 4, it would be about 1.4. 0, 1. Pi over 4 is at about 1.4. And an asymptote at half pi. Then I got negative 1.4, negative 1. That's all they gave me on my picture, but it's symmetrical. I would have another asymptote at 3/2 pi. All right, so this is what this looks like. You'll see. Okay, so this is the graph for secant. Which one of the trig functions goes with secant? Yeah, cosine. So if you were to draw a cosine wave in here, it would look like this. It fits right in the middle. It's like, so remember where I say it's cosine flipped over? It's like cosine's been cut in half and just opened up. So this part flipped up and that part flipped down. It's just cosine flipped up. So now let's look at cosecant. Cosecant is 1 over y. So starts out 1 over 0. So it starts out with an undefined. And then negative square root 2, negative 1, negative square root 2, undefined. So I'm drawing in my asymptotes at all the places where it's undefined. Then negative square root of 2, that's about negative 1.4. So at 3/4 pi, I would have a dot. And this one goes with sine. So you could fit a sine wave in there. That can kind of come in handy when you're trying to identify which one's which. Because if you could think, okay, well, cosine starts at 0, 1, and this one has a dot at 0, 1, so it has to be the one that goes with cosine. Okay, so let's look at the back so we can talk about some of the things that they have in common or don't have in common. I'm going to plug it into the calculator. So remember, since we don't have a secant and cosecant button, it tells you how to do it. 1 over cosine x will give us secant.
What the frizzle?
Looks like that. It says it up at the top.
I wanna go
1
home
over
soon.
cosine. There's no secant button.
Oh.
I've been working.
Okay, so it looks like that. So what is the y-intercept?
Where the
1.
things.
Yes, what value is it at? 1. What about the x-intercepts?
There are none.
There are none.
They're all asymptotes.
Yeah, that's right. It doesn't cross the x-axis anywhere. Where do the vertical asymptotes appear on this one? Half pies. At the half pies. Okay, so now remember yesterday when we were doing tangent and it looked like this over and over and over again. It went from negative infinity to positive infinity.
This one doesn't do that.
It does not do that, but it does go to negative infinity. So I start down here at negative infinity and then I start moving up.
Something like 1.
It stops at 1. So it goes negative infinity to negative 1. And it does touch there, so that's going to be a bracket. Let me move that up a little. And then it starts over again at 1 and goes to infinity. Is this periodic?
Yes.
Yes. How often does it repeat itself? The asymptotes happen every pi, but every 2 pi, because I have a hump on bottom and then a hump on top. And then it repeats a hump on bottom, a hump on top. So it repeats every 2 pi.
I love how I can actually answer these questions properly, and then I take this on a test. I'm like, I have no clue what this means.
Is it even, odd, or neither?
It is even.
Very good.
Really stupid. I'm gonna do the test and be like, neither, actually.
Because you can fold it in half and the sides match up. All right, so let's do secant. So that's going to be 1 over sine x. All right, it's coming any second now. There we go. You can see it. There it is. What's the y-intercept? There is none. There's an asymptote on the y-axis. X-intercepts? Also none.
This one's odd.
Very good. It is odd. Where do the he's just gonna shout out the things he knows. It's all good. You're right though.
It's like 12 steps from now.
But you're right. You're right. It is odd. Where are the asymptotes this time? At the pies. The range, again, it's the same range. It goes from negative infinity to negative 1 in union with 1 to infinity. And it does touch at 1, so that's why it's a bracket. It is periodic. 2 pi. And it is odd.
I know. I know. I had 2 in a row. That's like highlighted here right there.
The best you're ever gonna get.
Yeah.
Okay, so now get out the packet that we were just looking at because we've got the secants and cosecants in that same packet. And go ahead and go to this page.
Yeah.
Boom.
Yeah.